Ladies and gentlemen, good evening. Tonight we're going to talk about Java default methods on interfaces, and I am really practicing on drawing on this whiteboard that we have right here. I know it's yellow, but it is still called a whiteboard. What the situation is that in Java it has been possible to create default methods on interfaces for a very long time. I think since Java 8. And let me just clear this board right here. So the situation is that we have an interface, and then inside the interface we can actually implement default code if the implementing classes, the classes that implements the interface, if they don't want to, then they don't need to create the method that we have on the interface. Usually all the methods that we have on the interface should actually be implemented in the Java code. And the benefit with that is that we do not need to change existing code when we create a new method on the interface. So let us see in our situation right here, we will have some kind of space object template right here. So this is our interface right here. This space object interface is possible to, maybe there's a method where we can fly around. So maybe we can fly around and just fly around in space. And then we have a lot of classes. Then we have a round spaceship right here, or round spaceship. And then we have a square spaceship right here, square spaceship right here. And both of these, they implement this interface right here. And that means that then they need to have the fly around methods up on this class right here. That's how it works, right? Then we have the fly around up here. But then what actually happens then, we would like to add a new method. We would like to add the method go to hyperspace so we can travel between stars. So that means that we have a hyperspace method now on the interface. But we only need that for the huge ships right here. So that is only for the huge ships that we are going to develop now. But the other code up here, it has been into production for maybe for years, maybe for a long time. So we would like not to change this code up here, these classes here. We would like to keep them as they are. And then a new huge ship that we have down here. Here we have implemented the fly method, and we also want to implement the hyperspace method. So instead of, and that is cool, then we create the hyperspace method and we can jump between stars, and we are very, very happy. But instead of also us having to change all these classes that we're using here, maybe we're creating a third-party library that other uses. That means that suddenly all of their Java classes will actually turn up and show an error if this here is just a normal method. Then instead of that, we can add a default implementation of the hyperspace method. That means we can just write default in front of the as modifier. On a method, and then we can just actually implement a default implementation. So if no one overrides the method, then that will just be the situation. Maybe it could be like cough cough, we cannot jump into hyperspace because you do not have a hyperspace engine yet, or something like that. And then all the other spaceships, they are not able to actually fly into hyperspace. It could also be that there is that it can only fly to the closest stars. We don't know. It's also only up to our situation, but we could have a default implementation, so we do not need to ruin and break all the rest of the classes right here. Another a huge advantage with interfaces over abstract classes, because maybe you're just thinking, why don't you just create an abstract class here instead, and then you can just have all that code there instead. We have been able to do that for I think in all of the Java versions actually. So if you just use the abstract class, then we can just create the same methods there, the fly and the hyperspace right here. The thing with abstract classes is that we can only extend at this point in time at least one abstract class. So that means we can only extend one abstract class. Maybe these classes are here, or maybe they already extend another abstract class. And we cannot, maybe with this class over here, it extends another abstract class again. And that means that then we need to kind of wire everything together in a fashion where it actually doesn't make sense. Just in order to actually create an abstract class. The cool thing about interfaces, we can implement as many interfaces as we want to. So the default method, the purpose of the default method is not to break any code, and also to give the flexibility that we can implement as many interfaces as we want to with all these methods, of course. So, but let us just get started as usual and see a real situation. Of course, it's not that real again because it is spaceships and it's something out of my imagination. But I've created a I've created a Spring Boot project. That's what I want to say right here. New project. Then it shows Spring Initializer, Java SDK 13 and 14 is almost coming. So I'll also make a video about that soon. 11. And then it shows Gradle right here, just because I prefer Gradle. And then I ticked off Lombok. I wrote web right here, and then got the web. I'm not going to use the web. It was actually just to have some REST controller if I suddenly got an idea that where I want to create a REST controller or something like that. But I'm going to focus on the interface today. Then you press next, finish, and then then Spring. Oh, sorry. Then IntelliJ is actually indexing the whole project and building it for the first time for some minutes, and then you're ready to go after that. Let us create a new package right here. This package is called Space. The Space. Let us create an interface, new class, and an interface. In the beginning, I was actually I was very puzzled because when you say new class, then you actually can create an interface on enumeration and all that, and that's because all of these types actually goes as a class in the Java language. So that's just when you're talking to people, then you can say create a new class, create it as an interface, even though there's also a type that is called class. So yeah, but that's it confused me in the beginning at least. So when I was learning Java. So let us call this space object like this. Interface. We know that we need to have a fly around public void, or maybe a string. Yeah, I can return string. Fly around. Or we can also let us use void, and then I'll system out some cool stuff instead. Fly around, and then we just do like this. This is a normal way to create an interface. And then I need to create, the reason why it's gray right now is because I have no classes that actually implements the interface. So let us create a spaceship. New Java class, let's create a round spaceship like this. And this class is a class. Enter. Implement. And space object. And now I get an error because we have not implemented the method. I press Alt and Enter, and then IntelliJ is helping me. Yes, implement the fly around. I want to system out some stuff right here. And did you know actually, instead of using system out, you could just use the printf instead. I'll just show you that. So if you write south instead of south, then you can print f, and that means that then you can format the output as you usually would with the string format syntax instead. So let us just use that just for fun. So I'll say flying bus. And then I can actually write, I could have used a variable if that's what I want to use here. I can also write %n for a new line. So let me just do that. I can also have a new line here just for fun, just to show that I'm actually using printf instead of this usually system out print line instead. Okay, enough about that. There was one class. Let me create another class again. I'll call this is a square spaceship with the type class. Yes. Implement and space object. Implement method, fly around. And yeah, let's use system out this time. Print line. And I'll just say something like hopper, hopper, hopper. This is the sound that the square spaceship makes. I know there's no sound in space, but George Lucas all have convinced us all that there is actually space sound in space with the Star Wars movies, of course. So it's also okay that I make a sound in space in this example right here. Yeah, so that was two spaceships right there. Yes, that's fine. Let us create a test. So I'm gonna go down to my test folder right here. I'll create a new package space. And I'll create this new test right here. And it's a Java class, space test, yes. And it's just a normal JUnit test, like this, and then public void. Remember, the scope when you're creating tests need to be public, both on the class level and on the method level, or else nothing will be executed when you try to run the tests. Public void. Yeah. Test. Try spaceships like this, and then we say new round spaceship. And then we say dot fly around. Yes, good. New square spaceship. And I'm pressing Control D to copy a whole line, duplicate line. And so that's it. I have a round spaceship and I have a square spaceship, and then I just press play, run. And while we're waiting, I want to thank my good friend and Jan. I want to thank you, Jan, for asking me to create this video here and for pointing me into this direction. Then I remember that. And Jan, you know who you are, of course. Let me just go here. Flying, bus, hopper. Yes, that's it. So that was actually the unit tests. That is very cool. So then the next, now we have this code in production. The spaceships are flying around, making sounds in space. Everybody's happy. But now we come with this new huge spaceship right here. And this huge spaceship, it now says that all space objects now have the capability of going into hyperspace. It's actually not the huge space that determines that. Of course, that is a developer. That's me. So I say it could be cool if all the spaceships actually could go into hyperspace. So that is a new method that I make right here. And I'll start on developing it on the huge spaceship because that is the one that actually needs it. The rest of the spaceship, they don't need it right now. Maybe they'll need it in a while. Implements space object. And then I just implement. I have my two methods right here. Hyperspace, south, wham. So that's how hyperspace sounds like, I guess. And maybe we have multiple of these whams there. And let me duplicate this line. And let me just move it. Control X, cut, and Control V, paste right here. Fly around, that sounds a little bit different. How does that sound like? Raw, like this, raw. Yeah. So this is our huge spaceship. We're actually happy. We'd like to run our code. But what happens when I run my code right now? Let's just check. It tries to compile the code, and now I get compilation errors. What is this? The round spaceship doesn't have the method, and the square spaceship doesn't have the method. Our round spaceship is not abstract and does not override abstract method, hyperspace, and space object. Oh no, my code is falling apart, and all the people that use my brilliant code and use this as a third-party library, as soon as they upgrade, then all their code is breaking and falling apart because they are not implementing this method right here. Fear not, because there is something called default. There's default methods on hyperspace like this. Then we can just create a default method. And then we can create a default system out. This can be wiggle. So that is the sound that it makes if we have not written it yet. We know this is the default going to hyperspace sound that spaceships make if they have not overwritten this method right here. So let us try again, and we can also press build project or rebuild project. We do not need to execute the test to see that there are any errors. I didn't need to press rebuild. Then it actually clears all the classes and starts all over. It takes a little bit longer, but let's just see, and let's press play here. Maybe it doesn't take that long. We don't have that many classes. So yes. Flying, hopper. So now the code actually compiles, but of course we would also like to show what actually happens in the huge spaceship. So new, huge spaceship like this, and then fly around. And I also want to Now I also want to jump into hyperspace. Now you say, okay, why don't you just save this in a variable and then you can reuse the object twice? But there is a cooler thing we can do now. This is just a small trick. Instead of returning void, it's never good to return void. Let's just return a huge spaceship instead. So that's actually a pattern that surround this, where you always return self. Or this, sorry. So if you return this like this, yeah, of course we also need to change the signature in the interface. So up here, so now, okay, now I changed a lot of code anyway, and then we return this. It's just to show you a better pattern. That you always, instead of returning void, you can always return. But I cannot do that right here because the interface is not like that actually. Oh, that's actually a space object. So it's just be a space object. My mistake. Space object. It's not a huge spaceship that we want to return. We want to return a space object like this. And I'm going to copy the same right there, like this, and then return this. So the reason why the interface was complaining was that the interface, of course, is just a space object. It's not a huge spaceship. So that is why it was complaining here just before. But now we're returning a space object after we are making the sound, and we return and it just makes me that just makes my test look a little bit cooler in just a minute. Let me just change the code in my square spaceship. I need to return this also. And also in my round spaceship, I can also return spaceship, return this like this. So now I'm returning this all over. And that means now that down in my unit tests, then I'm actually getting an instance of, I'm actually getting this back. So that means that then I can just run hyperspace also. Then I don't need to have a local variable assigned to the spaceships. It just made my code a little bit shorter. That's yeah, that's all. Then I can write in 3 lines instead of 6 lines. So let me know what you think about this this style actually, where you always return something. You're using a method and then you're returning this that you then can use to call something else on. And here we see it flying, buzz. That is the fly around, and then the hyperspace. Then we have wiggle, and that is the fly around in the square. Oh no, sorry. These 2 lines, that is the fly around method, and then this line right here, that is the default sound of hyperspace when we have not implemented or written the method, the default method that we have on the interface. Then we have hopper. That's this fly around method. Then we have wiggle again. This is the default, and then in the big spaceship right here, first we say raw when we are flying around. And then we say wham when we go into hyperspace with the huge spaceship. So that was the explanation of oh, I don't need to write public. Okay, public is actually wrong. So let me just remove public. But that's actually because we're not using it inside the spaceships itself. Let's forget about the scope for now. So we will keep it as public. But that is actually what I want to show you tonight. I'm going to upload the code, push the code to GitHub as usual. And of course, as usual, I also hope to see you again soon. And thank you very much for watching. Have a great evening. Bye-bye.